In this section, we're going to talk about the composite design pattern. We use this pattern in situations where we want to represent a hierarchy of objects. Let's look at a real example. Here I'm using Keynote on Mac, which is like PowerPoint on Windows. We can add a couple of squares and let's say a couple of circles. Here's one circle and here's the second one. Now, I can select these two squares and put them inside a group. Now, if I move the group, all the objects, all the shapes inside the group will be moved together. Similarly, we can resize a group. And once again, all the objects inside this group will be resized together. So let's put these two circles inside a group as well. Now, what is interesting here is that we can treat these groups like individual shapes. So we can select both these groups and put them inside a new group. Now, we can move this group, we can resize it, we can change its angle, all sorts of things. So we are treating a group or an individual shape the same way. We can resize or move a shape or a group the same way. So basically what we have built here is a hierarchy. At the top of our hierarchy, we have a group. This group contains two subgroups. The first group contains two squares, and the second group contains two circles. We can move or resize an individual object or a group. If we move a group, this operation will apply to all the objects in that group, whether they're individual shapes or other groups. This is where we're going to use the composite design pattern. Basically, whenever we have a hierarchy and we want to treat the objects in this hierarchy the same way, that is when we use the composite design pattern. As another example, think of your file system. On a file system, we have files and folders. A folder can contain files and other folders. If you move a folder or delete it, this will impact all the files and folders in that folder, right? So let's go ahead and represent this concept in code. So in this project, we're going to add a new package called composite. First, let's add a class called shape. Now, this is potentially the base class for different types of shapes. So we can have a square and a circle class that extend the shape class. But let's not worry about those individual classes. Instead, we're going to focus on shapes and groups. So each shape should have the ability to render or draw itself on the screen. So here we need a method called render. And for simplicity, we're going to print something like render shape. Now let's add a group class. Group. A group object can have 0 or more shapes. So here we need a list of shape objects. Let's import the list interface and set it to a new array list. We also need a method for adding a shape to this group. So public void add, which takes a shape object. And here we call shapes.add shape. Pretty straightforward, right? Now, we also need a method for rendering a group. So public void render. Here we should iterate over all the shapes in this group and render each shape. So for shape in shapes, we're going to call shape.render. Similarly, if we had a method for moving or resizing a group, we would have to iterate over all the shapes in that group and move each shape separately. Now let's go to our main class and see how we can represent a hierarchy. So first, I'm going to create a group. Let's call it group 1. And I want to add two imaginary squares in this group. So group 1.add. Let's add a new shape. So this shape is going to be our imaginary square. Let's duplicate this line. So in this group, we have two squares. Now let's create another group that would contain two circles. So new group. And here we add a new shape. This is going to be our imaginary circle. So in this group, we also have two circles. Now we want to combine these two groups inside a new group. So let's create a new group object. Now, if we call group.add and pass group 1, we get a compilation error because the add method expects a shape object. Our group and shape classes are completely different. They have nothing in common. So with this structure, we cannot add a group inside a group. To solve this problem, we can go back to our group class and replace this shape class with the object class. Because in Java, every class directly or indirectly extends the object class, we can pass any kind of objects here. So let's also replace the shape with the object. Now we have a compilation error in the render method because when we iterate over the list of shapes, we're dealing with instances of the object class, and this object class doesn't have a render method. So here we have to write code like this. Let's add a block. In this block, we have to see if we're dealing with a shape or a group object. So if shape is an instance of the shape class, then we need to convert or cast this to a shape object so we can call its render method. So we type shape, then prefix it with the type we want to convert it to. We want to convert this to a shape object. So we add the target type inside parentheses. Now we wrap this whole expression inside parentheses. Now when we type dot, we can see all the members of the shape class. So this is how we can cast or convert an object in Java. So if we're dealing with a shape object, we can safely convert or cast it to a shape instance and then render it. Otherwise, we have to cast this object to a group instance. So we type group, shape, and then here we can see the members of a group object. So we can call the render method. Now for clarity, I would prefer to rename this field to objects because we are not necessarily dealing with shape instances. And also in this for loop, let's rename this local variable to object. So if this object is an instance of the shape class, then we can convert it to a shape instance and render it, okay? With this change, we can go back to our main class and add a group inside another group. So we're building a hierarchy, right? Now let's add the second group here, group 2. With this, we can render our top group, and this will render all the shapes inside this group recursively. Take a look. So run. We have 4 render messages. The first 2 are for rendering our squares, and the others for rendering our circles. So this is how we can represent a hierarchy. And by the way, we haven't used the composite design pattern yet. We're going to use the composite design pattern to solve a problem in this implementation. What is that problem? Well, look at the group class. With this implementation, we have to check the type of this object and explicitly cast it to a new type before we can call the render method. If we had another method like move or resize, we would have to repeat the same structure. So we would have to iterate over all the objects in this group. For each object, we would have to see if we're dealing with a shape, then we would have to convert it to a shape instance. Otherwise, we would have to convert it to a group instance. So this makes our implementation a little bit complex and, quite frankly, ugly. The composite design pattern allows us to treat these objects the same way. Whether we're dealing with an individual shape or a group, we can work with them the same way. We'll look at how it works in the next video.